Today what we're going to look at is equations as relations. So the last few days we've been looking at ordered pairs and relations, which remember relations are just a set of ordered pairs. So what we're going to look at today is if we have an equation and we're given a domain or we're given a range, how to find the solution set. So let's go ahead and take a look first at the steps for solving. So the first step for solving is that we need to solve our equation for either the domain or range value, and this is dependent upon what you're given. So if we're given the domain, we need to solve for the range. So you're solving for the opposite. So remember, when we talk domain and range, it's x then y. So which one comes first alphabetically? So if we're solving for the range, we're solving for our y. So we need to subtract 2x from both sides. So I'm going to say y equals, we could say 1 minus 2x, or we could say negative 2x plus 1, either way. The next step is that we need to replace the variable with each value given individually. So we see that we have these three domain values. So we need to individually take the negative 4, the 2, and the 4 and plug them into this equation here to find the corresponding y value. So we say y equals 1 minus 2 times negative 4. So we say, okay, negative 2 times negative 4 is a positive 8, and 1 plus 8 is 9. So we have our solution set then of negative 4, comma, 9. Now we're going to plug in 2. So we say y equals 1 minus 2 times 2. Negative 2 times 2 is a negative 4. 1 minus 4 is a negative 3. So we have a solution, and part of our solution set is the coordinate 2, negative 3. And our last one, we say y equals 1 minus 2 times 4. So that's 1 minus 8. 1 minus 8 is a negative 7. So we have the coordinate of 4, negative 7. So we see then that our solution set is negative 4, 9, 2, negative 3, and 4, negative 7. So you need to do that for each domain value that they give you. Let's take a look at another one. This time though they give us our range. So that means that we need to solve for the domain. Solve for domain. And in this case, it's our x. So we need to say, I'll just rewrite it down here so we have enough space. We need to add 3y to both sides. We have 2x equals 12 plus 3y. We take and we divide both sides by 2. And we could leave it just like this and say x equals 12 plus 3y over 2. Or you could say x equals 6 plus 3 halves y. It doesn't really matter. Okay, so now what we're going to do is we're going to take and we're going to plug in each of these values in for our domain, or sorry, in for our range in order to solve for our domain. So we say x equals 12 plus 3 times negative 10. Kind of covered up the negative there, but it's there. And so now we have 12 plus negative 30, or you could say 12 minus 30, divided by 2. And so we have a negative 18 over 2, which is a negative 9. So part of our solution set then is, now make sure we get the order right, x is negative 9, and then our range, which is what we've been plugging in, is negative 10. Okay, let's do negative 6 now. So we have x equals 12 plus 3 times negative 6 equals 12 plus a negative 18. Again, we could say minus 18. And then, divided by 2, divided by 2. Here we have 12 minus 18 is negative 6. Divided by 2 is negative 3. So again, we come here, make sure that we get this in the right order. This is our x value, and our y value is negative 6. Okay, now to the negative 4. X equals 12 plus 3 times negative 4. which is 12 minus 12 divided by 2, which is 0 divided by 2, which is 0. So now we have 0, negative 4. And our last one, x equals 12 plus 3 times 2 divided by 2. 12 plus 6 over 2 is 18 divided by 2, which is 9. So now we have the final point of 9, 2. And so this is our solution set here. And notice how we just had to take each of those domain values, plug them in for our y, and get the corresponding range value, and then put them in as ordered pairs. Our final thing is we want to look at how we can write an equation and then use that in order to solve. And so what we want to do is, let's take a look at this example here. It says employees of Smith's Hardware work a minimum of 40 hours a week. Okay, so they all work at least 40 hours a week and earn $12 an hour. For each hour worked beyond 40, the pay is $15 an hour. What is the weekly pay of an employee who works 40, 43, and 50? So in a sense, these are our domain values. So let's go ahead and write an equation, and then we'll find each of these values, corresponding values to our domain. So we have we'll call pay P, and we have 40 hours times the 12 hours that they work, plus we have $15 for every hour after 40. So let's call this H. So our domain is going to be our H value. Our range will be our P value. And so what we need to say is that our H actually has to be taken, or we need to take 40 away from H, because it's every hour after 40 hours. So if we worked exactly 40 hours, we wouldn't have any extra time, which we're going to see here in this first one. So our equation looks like this, and now that we have our equation, we can actually come here and say, well, this is 480 plus 15 times H minus 40. And so we can now use this equation here in order to find the values for 40 hours, 43 hours, and 50 hours. So let's go ahead and do that. So we have P equals 480 plus 15 times 40 minus 40, which this is 0. So then 15 times 0 is 0. So on the first one, it's $480. And make sure we label here. So that's A. Okay, B is P equals 480 plus 15 times 43 minus 40. So we have 3 hours extra that they are working, and so that's 480 equals P, and so P equals 480 plus 15 times 3 is 45. And when we add 480 plus 45, we have 5, 2, carry the 1, $525. Again, let's label. Alright, and finally, to finish off, C, P equals 480 plus 15 times 50 minus 40, which is 480 plus 15 times 10, that's 150, 480, and when we add 480 and 15 together, we have 0, 3, carry the 1, $630. So notice how using our equation we're able to find multiple values rather quickly. Hopefully this was helpful for you. Thank you for watching.